Good morning, grade 10. Now, our lesson are going to continue what's the refraction of the light. Now, first of all, we have here an image. If you put a spoon inside a glass of water, as you can see, the line between the two mediums, which is air and water, inside the glass, you can see at this line that the spoon is bending. The spoon is bending here. So it's giving you another position for the spoon inside the water. It's not real, it's a virtual image, but the real position will be in the same position, okay? But because of the light is refracted when it moves from one medium to another, so you can see that the spoon has changed its position. Now, this is an example from daily life. Now, from here also the same. As you can see, the picture up and down are different. Up and down are different in air, and then in water are different. In air and water are different. Now here, refraction of light. These are another examples of refraction of light. If you put a metal inside the glass of water, the same, it will bend, okay? Because the light bend or refract when it enters another medium. The same here. Now, points to remember. When a ray of light passes from air to water, its speed changes. Due to this, there is a change in direction of the ray. That change in direction suffered by a ray of light as passes obliquely from one optical medium to another with different optical densities is known as refraction. So ray of light, it changes its speed while it's entering different mediums. So when it changes its speed, it refracts. When a ray of light is incident on a surface separating two media, a small fraction of light always gets reflected. Now, refraction can make an object appear to be on a different position. And you have to remember always the spoon inside the glass water. Why does light refract? When a ray of light goes from an optically rarer medium to an optically denser medium, the speed of light decreases and the light ray bends towards the north. So as you can see here, this is the incident ray of light, and this is the normal. What happened? See, this is air, and the one in green, colored in green, is water. So this is different medium. What will happen to the ray? It will refract. It will refract. As you can see, the angle of refraction is I. Sorry, the angle of incidence is I. And it is the angle between the normal and the incident ray. And here the angle of refraction is the angle between the refracted ray and the normal. Now, see the next page. Now, as you can see in this example, this is air, that is water, and that is I, the incident angle, and that is R. So this is the reflected angle, and this is the refracted angle. As you can see, the reflection should be in the same medium, while the refraction should be in the two different mediums. Also, you can notice that the two angles here, the incidence angle and the reflected angle, are equal to each other, while for refraction angle, it's smaller than them. It's smaller than them. Now, when a ray of light travels from denser medium to rarer medium, the ray of light bends away from the normal. Now, as you can see here, this is the glass, that's air. Now, the light is passing from glass to air. What will happen? As you can see, this is the angle of incidence now, it's so small. While angle of refraction is so big. Why? Because light moves faster in air. Light moves faster in air. That means that the angle of refraction here will be so big, bigger than the angle of incidence. Now, refraction through a glass slab. As you can see, this is a slab of water. Okay. Now, where is my light ray? That is my light ray. I-O. This is my light ray. Now, it's hitting the surface at the point. Now, put your normal, draw the normal, which is a line, straight line, normal to the surface. Now, you can get the angle between the normal and the incident ray as angle I. Now, it will refract, of course, because it's changed the medium and because the speed of light changes. So the speed of light inside the glass is slower than the speed of light in air. Now, R is smaller than I, which is angle of refraction. What will happen again to the light? It's going to refract again. It's going to refract again by angle E. So angle of refraction here is bigger than that angle of refraction. And it's so big. Why? Because the light now is entering the air. And we said before that the speed of light in air is so fast than the speed of light in glass. So the angle of refraction will be bigger than the angle of refraction inside the glass. Now, what are the effects of refraction? As you can see, this is the same as the spoon we have said before. So this is a pencil, and it appears to be here, but the real position will not be here, it will be there. Okay? So why do we see it like that? Because the light refracts when it enters two mediums, which is air and water. Now, this is the same. Now, refraction of light, the light bouncing the fish. Now, this is an example of how do we see refraction of light in our life. Now, this is a fisherman standing up a hill, as you can see him, and he's looking at the fish from his position. What will happen? Okay, now this is a light ray which is coming from his eyes and going to the fish. As you can see, this is the light ray is coming from here, from the fish. The light ray is coming from the fish, from a sun, from course from the sun here. So the sun is sending a lot of light rays, and you can see that the fish has one light ray. Now we are taking only here in our picture one light ray. Of course, there are a lot of light rays. Okay. Now this is my light ray. Now it has an angle of incidence here. So this is the normal with the surface of water, and it's so small. See, this is the angle of incidence. Okay. What about the angle of refraction? What about angle of refraction? Now, angle of refraction will be so big. Where is my angle of refraction? That one. This is my angle of refraction. That one. Okay, not that one. That one. Between the normal and the refracted ray. So R here is bigger than I. So where does the fisherman see the fish? He sees here. This is the apparent position, but it's not real. This is what we're going to see it. But the real position is here. See, this is the real position. And that one is the apparent position. Okay. So the light bouncing of the fish into the eyes of the spear fisherman is refracted as it moves from one medium to another. The wave speeds up, bending it away from the normal, and the eyes of the fisherman assume light travels in a straight line, so the fish appears to be above its actual position. The fish appears to be above its actual position. Okay. Thank you so much. Great 10 today. If you have any questions, please contact me on WhatsApp.